Welcome to Easy Elim, Learning Simplified. My name is Ruth, and today we are going to be looking at the topic chemical families. And the subtopic for today will be alkali metals. So we're going to do a little bit of introduction to alkali metals, but first we are going to look at what chemical families are and what are some of the chemical families we have in the periodic table. And then we are going to dive into alkali metals in details, look at some of the properties of alkali metals. So for this session, you start the introduction bit, and then we are going to look at the differences between the atomic radius and ionic radius of alkali metals. And then we are going to tackle some questions at the end of the session. So we'll start with what are chemical families. So elements are usually classified on the periodic table depending on the number of valence electrons and also energy levels, which we discussed in the previous videos. So the number of electrons usually determine the group to which the element belongs to, and then the number of energy levels determine the period to which that element belongs to. So elements that are in the same group are usually referred to, they belong to the same chemical family. And a chemical family refers to a group of elements that have the same number of valence electrons, and so they belong in the same periodic group in the periodic table. So when you look at some of the characteristics of elements in the same chemical family, the first thing is that they have the same number of valence electrons, that is the outermost electrons in the outermost shell. Next, they show a uniform graduation in physical properties. Later on, you're going to look at the physical properties of alkali metals, and you see on the trends, and you notice a uniform graduation, either an increase or a decrease with specific reasons. And then they have also similar chemical properties, although you notice a trend also in their reactivities later on. So the main chemical families that we are going to discuss in chemistry, this Form 2 work, will be alkali metals, which we are tackling today, and then alkaline earth metals, halogens, and noble gases. You notice we do not talk about group 3, 4, 5, and 6, although we will also discuss some of the properties of these elements in other topics. Like in Form 1, we talked about metals reacting in air, and we tackled metals in these groups, but you're not going to go to details of this family. This is going to be beyond high school. You're going to do them in campus. So these are the four main chemical families that we are going to concentrate on in this lesson. So we'll start with the alkali metals. Alkali metals usually have one valence electron, and so they're in group 1 of the periodic table. They are usually metallic in nature, and when you look at the members of the group, they are as follows. We have lithium at the top of the list, then sodium, followed by sodium, and then potassium. So lithium, sodium, and potassium is what we are going to be tackling in this subtopic. But rubidium, caesium, and francium, we are not going to be discussing them because they are beyond the 20 elements. So you discuss this in details later on when you go to campus. And then when you look at the configuration of this element, this is how they look like. And you notice we have only placed only the 3 elements. So we have lithium, we have sodium, and potassium. And if you look at their electronic arrangement, you see they're in different periods, but they're in the same group because they have each one electron in the outermost shell. So you can see where they are in the periodic table. Remember, we also have hydrogen in the periodic table, but we do not refer hydrogen as a metal. Hydrogen can actually be placed in 2 places in the periodic table. We are going to look at that later. But when you discuss this group, we are starting from lithium. sodium and potassium, rubidium, calcium, and francium. So this is where they are on the periodic table. So starting on the trends in the graduation of some of the properties, we are going to start with the atomic radius and ionic radius. And then in the next lesson, we are going to look at other properties of this group. So when we look at the atomic radius and ionic radius, so what is atomic radius? This is the distance between the center of the nucleus and the outermost energy level. So if you look at the distance between the nucleus and the outermost energy level, whatever we get there, that distance is what we refer to as the atomic radius. It needs to be on the distance between the nucleus and the most outermost energy level, the last energy level or the last energy shell. And then the ionic radius now will be for the ion. So if we take, for example, the diagram that we have on the side, and we have formed an ion. And remember, we said in the previous classes, whenever we form an ion, we must enclose the ion with brackets. So the distance between the center of the nucleus and the outermost energy level of an ion, that is what we refer to as the ionic radius. This can be a cation or an ion. So we are going to look at the details of them later on. So that is what we define atomic radius and ionic radius. So next we are going to look at the trend now of the atomic radius and ionic radius down the group. So when you look at the trend, it increases down the group from lithium to potassium. So the reason why it increases is because there is an increase in an energy level down the group. So you'll notice that lithium has only 2 energy levels, sodium has 3 energy levels, potassium has 4 energy levels. As you can see, the atomic radius is going to increase. So when lithium forms an ion, the ionic configuration becomes 2. And when sodium forms an ion, the ionic configuration becomes 2.8. When potassium forms an ion, the ionic configuration becomes 2.8.8. Remember, they form ions by losing, so they form a cation, which is positively charged. So even if you look at the configuration of the ions, you notice still down the group there is an increase in one energy shell of the ion. So you automatically notice that the ionic radius as well increases down the group. So when we now compare the difference between the atomic radius and ionic radius of the same element, you notice that the atomic radius will be larger or bigger than the ionic radius of the same element. So first of all, we know alkali metals form ions by losing electrons. So when they lose electrons, they do not only lose those electrons, but they also lose an entire outermost energy level. And even if the specific, you see, the specific valence electrons have been lost, there is a reduction in the energy level for the ion. Let's take, for example, when we look at our sodium. Sodium has a configuration of 2.8.1. So if you look at the number of energy levels of sodium, there are 3 energy levels. And then sodium reacts by losing 1 electron. So the sodium ion, as we discussed before, is going to have a configuration of 2.8. So if you were to compare the sizes, you notice that the sodium atom has 3 valence electrons, and then the sodium ion has 2. Not valence electron. It has 3 energy shells, and the sodium ion has 2 energy shells. So if you compare the sizes, definitely the size of the atomic radius will be larger, and then the size of the ionic radius will be smaller. So apart from the loss of a whole energy shell, remember we are losing electrons. So the moment we lose electrons, there is an increase in the nuclear charge. How does the nuclear charge increase? So let's take, for example, the sodium. The sodium atom that we had, neutral atom, it has 12 protons in the nucleus, which are positively charged. 11 protons in the nucleus and 11 electrons, which are negatively charged on the energy shell. So it is neutral, meaning it is the number of protons and electrons cancel out each other. They are equal in nature. When you look at the ion, however, you notice that the number of protons will remain the same because they are in the nucleus. But when you look at the number of electrons, they become 10 electrons. So you know we have when you look at how they are going to cancel out each other, we will have an extra proton that do not have an electron to balance out with. So it causes the overall ion to be positively charged. So we say there is an increase in the nuclear charge because the nucleus now has more protons in comparison with the electron. So what happens? It pulls the remaining electrons closer to the nucleus. So you can be told to explain the two reasons why the atomic radius is larger than the ionic radius. So the first thing we said is the atomic radius has more valence shells than the ionic compound. So you can see, for example, sodium has three valence, it has three energy shells, while the sodium ion has. And the second reason is that when the first electron is lost in sodium atom, what happens? There's an increase in the nuclear charge, which pulls the remaining electrons closer to the nucleus. So those are the two reasons why the atomic radius is larger than the ionic radius. So let's look at a few questions in regards to what we have discussed. So state and explain the trends, the following properties down the group. So state and explain the trends in the following properties down the group. So these are the properties: atomic radius. So we said that the atomic radius increases down the group. And the reason why it increases down the group, there is an increase in one energy level or shell down the group. And then what is the trend in the ionic radius? It also increases down the group. The reason why it increases down the group because there is also an increase in one energy shell down the group. And then how does the ionic radius and atomic radius of an element compare? So we said that the atomic radius is larger than the ionic radius. This is because the atom has an extra energy shell in comparison to the ion. And we talked about the loss and the effect on the nuclear charge, and the loss of an electron causes an increase in the nuclear charge, hence the outermost electrons are attracted strongly. So this gives us now the two reasons why the ionic radius and the atomic radius is different and why the atomic radius is larger than the ionic radius. I hope you have been able to understand those two properties. In the next session, you're going to look at other physical properties of this group in details. See you then.